Alright, let's jump on this lab, see what we've got here. On router 3, I'll do a quick show interface Ethernet 0, and you can see our address is 172.12.23.3/25. And we'll go ahead and send a ping over to router 2. And we'll send another one just to make sure. Losing the first packet's no big deal right after you set a new address. But there, let's run show interface Ethernet on router 2. And you can see 172.12.23.2/24. And there shouldn't be any problem sending a ping back, but it only takes a second. So 23.3, 23.2, we're good to go on the pings. So let's go forward then and start with our OSPF adjacency, or we hope. And we're going to do that on router 3 first. Might see some console messages about OSPF on this one. I'm going to go over this again in another video, but very quickly, this process ID, it's locally significant only. It is not advertised to a downstream router and has nothing to do with our neighbor adjacencies. So we're just going to go ahead and pick one here. And we'll start with our network command. First thing we have to put in after network, you would expect, is the network number. And remember, with OSPF, we're using a wildcard mask. There's a video at the beginning of the OSPF section that's a good review, or especially if you haven't seen wildcard bits before, you definitely want to watch it before you watch the rest of the OSPF section, because we're always using wildcard bits in OSPF. So if we're using a wildcard mask here, and we've got a /25 network on router 3, which is what we have, what is the wildcard mask going to look like? Because remember, the wildcard mask is kind of a bizarro subnet mask. We put zeros, So what would that be? You remember, if we put zeros for 25 zeros at the beginning of a binary string, that means we have how many ones left? We have 7, and that would look like what? Looks like 000.127. That's our wildcard mask for that particular network with a /25 on it. Now, we're not done yet, because we have to put the word area in here, and then we've got to put the area ID in. We're going to put these both in area 0, our backbone area. I strongly recommend you stick with the decimal value. There's no real reason to get cute and put it in IP address format. It's good for you to know that that is actually legal. I don't know if you'll see that on the CCENT exam. It's more of an advanced thing, but really most people, I have very rarely seen that used in production networks. I would just stick with the decimal, which in this case is 0. So that's our legal command, 172.12.23.0.000.127, area 0. Let's go over to router 2 and put in the appropriate commands here. Now the network's going to be the same, but what's the mask going to be? We're on a /24 segment here, according to this interface, and that's going to be 000.255, and then area 0, and that's it. So every once in a while, very quickly here, since on Ethernet segments, how often do our hello packets go out? They go out every 10 seconds, so when you're building adjacencies, you usually don't have to sit around and wait very long, and usually you'll see a message on the console that says adjacency has been built with such and such. But to verify your adjacencies and get some other fun information, we can run show IP OSPF neighbor. And this is sad, because whenever you run a show command on a Cisco device, and it just drops to the next line, and doesn't show you anything, that means literally it's the old joke, hey, nothing to see here. There is literally nothing to show you. So we don't have any neighbors, which means that it does look like that mask is causing issues. But since we just did that, we know what the problem is. But what if, in a more typical scenario, you and I come into a network and we're the troubleshooter, and they're saying, well, I'm building this OSPF adjacency, but I don't know what the problem is. And the thing is, you can just go blind just staring at a config and trying to spot the problem. I don't mind looking at configs at first just to see what's going on, but after that, you can't just stare at a config for 15 minutes trying to figure it out. You want to run the right debug. And the right debug for us is all of these. Just kidding. The adjacency. That's the only one that we're going to deal with right now. And it's just ADJ. You don't even spell out the word adjacency. As a matter of fact, if you do, the router is going to tell you what is this. It is literally just ADJ. So let's put that in, and I bet we get some feedback pretty quickly again, since our hello packets are traveling around every 10 seconds, because right now routers 2 and 3 are sending hellos to each other and just saying, you know, hey, I'm trying to form a neighbor relationship, what's going on? And very quickly we get a little bit of information. And one reason I love this debug, nothing is put in arcane terminology, words that you might not have seen before. There's none of that certain vendor stuff where you just get a huge string of hex characters. You just get plain English. And right there, OSPF mismatched hello parameters. Okay, fantastic. Now, which hello parameters? Because we've only discussed one so far in the course, and that's mask. So, you know, between you and I, we know what the problem is here, but it could be something else. You know, like I said, we just walked in and we just run this command. Well, let's start looking at this, and we got something here called a dead. We don't know what that dead is yet. We haven't gotten to it yet in the course, but we can see right there that with a 40 and a 40, that's a match. Because I'm just telling you from experience, you're going to see things in debugs, values that you might not recognize, but if you stay calm and just parse through it, you can see what's going on. Even if you don't know what dead and hello are, and it's the first time you watch the video, we haven't gotten there yet, you can see that these are matches. So that's probably not your problem. I would say that there is a problem down here with our mask statement, considering they're different. So when you get told there's a mismatch and it's showing you this mismatch, not only do you know that it's a hello adjacent, an adjacency issue with the hello parameters, it's even telling you which one it is. So what we will do is go over to router 3 and take care of that. First, I'm going to go into the OSPF config and remove that previous network statement that I put in. And how am I going to do that? Because that was a long statement, right? And those of us who don't like to type, maybe you don't want to do that. Remember, just use your up arrow, and it's going to run through your previous commands, and Control A moves you to the front of that line. I do like that shortcut. Bang. Then if you just wanted to run it again until you got to network, all you got to do is put 255 right here. And that's it. Now, let's change that IP address on the interface. Some people like to close the interface when they do this, or take the old one off first. I don't mind that either, but I'm just going to overwrite it. And now that they've got the same mask, let's see if anything's going on yet. Oh, something's going on. We got that adjacency change, and there's what we expect to see. You could see immediately I couldn't even get show IP OSPF neighbor all the way out because we got the message there, process 1 neighbor 2222 on Ethernet 0 from loading to full, loading done. Now, where's it getting that 222 from? That's something to keep in mind for later in the OSPF section of the course. That's kind of interesting because you can see it's showing that we have a neighbor ID, but it's showing 2222. And we didn't even enable router 2's loopback, which was still on there from a previous lab. We didn't even enable that with OSPF, did we? That's something to keep in mind here for later in the course, but you can see immediately we got our neighbor adjacency when we fixed that issue. But more importantly, since we knew what the issue was, we're the ones who caused it and did it on purpose. But you see now how to verify your neighbor relationships with show IP OSPF neighbor, and also a very important debug IP OSPF 80J, because you never want to be the person that's just staring at the config hoping to spot the issue, because our config here is pretty small, right? I mean, it's just not that big. It'd be pretty easy just to do show config and go through it and say, okay, here's the problem. But I'm telling you, as your configs get bigger and bigger and bigger, that gets more and more difficult. That's why you want to start working with debugs now. That's the one thing I wish someone had told me when I was going after my CCNA, the importance of using debugs to see what's going on. So now that we have cleared up that neighbor relationship issue, we're going to cause another one, and we're going to do that with some of those values we saw in that adjacency, in that debug rather, and run some more debugs and run some more tests. So I will see you in the next video.